The Amish community, known for their commitment to simple living and rejection of modern conveniences, has developed sophisticated methods for heating their homes without relying on electricity or natural gas. Their approach to home heating reflects centuries of accumulated wisdom, practical ingenuity, and the deep understanding of thermodynamics that predates modern heating systems. These time-tested techniques not only provide effective warmth, but also embody principles of sustainability, self-sufficiency, and resourcefulness that have allowed Amish families to thrive in various climates across North America. The foundation of Amish home heating lies in wood-burning stoves, which serve as the primary heat source in most Amish households. These stoves are not merely functional appliances, but carefully selected and positioned heating systems that maximize efficiency and heat distribution. The typical Amish home features a large, centrally located wood stove, often placed in the main living area or kitchen, where family members spend most of their time during cold months. The strategic placement allows heat to radiate throughout the home's common areas while creating a warm gathering space for family activities. Wood selection represents a crucial aspect of the Amish heating strategy. Community members typically begin preparing for winter heating needs well in advance, often starting wood cutting and splitting activities in early spring. They prefer hardwoods such as oak, maple, hickory, and ash, which burn longer and produce more heat than softwoods. The wood is cut to specific lengths, typically 16 to 20 inches, to fit properly in their stoves. Proper seasoning of wood is essential, with most Amish families allowing cut wood to dry for at least one full year before burning, ensuring optimal heat output and minimal smoke production. The wood preparation process involves the entire family and often extends to community cooperation. Men typically handle the felling and cutting of trees, while women and children assist with splitting and stacking. Wood is stacked in covered areas, usually near the home but protected from rain and snow. The stacking technique itself is an art form, with logs arranged to promote air circulation and prevent moisture retention. Many Amish families maintain multiple wood piles at various stages of seasoning, ensuring a continuous supply of dry, ready-to-burn fuel. Stove management requires considerable skill and attention. Amish homemakers develop expertise in controlling airflow, timing fuel additions, and maintaining consistent temperatures throughout the day and night. The process begins before dawn, when someone rises early to rekindle the fire from overnight coals. Throughout the day, family members monitor the stove, adding wood as needed and adjusting dampers to control the burn rate. Evening preparation involves loading the stove with larger logs and adjusting airflow to maintain a slow, steady burn that will provide heat through the night while preserving enough coals for easy morning rekindling. Beyond wood stoves, many Amish homes incorporate multiple heating strategies to maximize warmth and efficiency. Kitchen cooking stoves, also wood burning, contribute significant heat while serving their primary function of meal preparation. These stoves, often large cast iron models with multiple cooking surfaces and warming compartments, remain active throughout the day during meal preparation and baking activities. The heat generated from cooking activities provides substantial supplementary warmth, particularly in kitchen and adjacent dining areas. Coal heating, while less common today, remains part of the heating repertoire in some Amish communities, particularly those in Pennsylvania where coal mining has historical significance. Coal stoves burn longer and hotter than wood, requiring less frequent attention but demanding different management techniques. Coal heating requires specific stove designs with different airflow systems and presents unique challenges in terms of fuel preparation and ash management. However, coal's high heat output and long burn time make it attractive for overnight heating and during periods of extremely cold weather. Passive solar heating techniques, while not explicitly acknowledged as such, form an integral part of Amish home design and heating strategy. Traditional Amish homes are oriented to maximize southern exposure, allowing winter sun to warm interior spaces naturally. Large windows on the south side of homes capture solar energy during the day, while smaller windows on the north side minimize heat loss. Thermal mass in the form of stone or brick elements absorbs solar heat during the day and releases it slowly during cooler evening hours. Building design and construction techniques play crucial roles in heat retention and efficiency. Amish homes typically feature thick walls, often constructed with multiple layers of materials that provide excellent insulation. Traditional building methods include the use of natural insulation materials such as sawdust, wood shavings, or even corn cobs between wall studs. These materials, while seemingly primitive, provide effective thermal barriers when properly installed and maintained. Basement heating systems represent another sophisticated aspect of Amish heating methodology. Many Amish homes feature basement wood stoves or furnaces that heat the entire house through natural convection and ductwork systems. These basement heating systems often include large, centrally located furnaces that burn wood or coal, with heat distributed through a system of ducts and registers throughout the house. The basement location protects the heating equipment from weather while providing a more even heat distribution than single-room stoves. Heat distribution throughout multi-story homes presents particular challenges that the Amish address through various ingenious methods. Stairwells often serve as natural heat chimneys, allowing warm air to rise to upper floors. Strategic placement of floor vents and registers help direct heated air to specific rooms. Some homes feature heat ducts connected to the main stove or furnace, though these systems rely on natural convection rather than electric fans. Thermal curtains and room sealing techniques help maximize heating efficiency by containing heat in occupied areas. Heavy curtains, often homemade from wool or other insulating fabrics, are drawn across doorways and windows during cold periods to reduce heat loss. Rooms not in regular use during winter months may be temporarily sealed off, allowing families to concentrate heating efforts in primary living spaces. This selective heating approach reduces fuel consumption while maintaining comfortable temperatures in essential areas. Personal warming strategies complement whole house heating methods. Heated stones or bricks warmed on wood stoves and wrapped in cloth serve as portable heat sources that can be carried to bed or placed in specific seating areas. Hot water bottles filled with water heated on the stove provide personal warmth during cold nights. Thick, layered clothing designed for indoor wear helps individuals maintain body heat with less reliance on ambient room temperatures. Cooking and baking activities are strategically timed to contribute maximum heat during the coldest parts of the day. Bread baking, which requires sustained high oven temperatures, is often scheduled for cold mornings or afternoons when the additional heat is most welcome. Large meals requiring extensive cooking provide substantial heat output while preparing food for the family. Canning and food preservation activities, typically conducted during colder months, generate considerable heat while accomplishing necessary household tasks. Community cooperation extends beyond wood preparation to include shared knowledge and mutual assistance in heating-related activities. Experienced community members share expertise about stove operation, wood selection, and heating efficiency with younger families. During particularly harsh weather, community members check on each other's heating situations and provide assistance if needed. Knowledge about heating techniques, stove maintenance, and fuel preparation is passed down through generations as part of essential life skills. Maintenance and upkeep of heating systems require regular attention and specialized knowledge. Chimney cleaning, performed annually or more frequently depending on usage, prevents dangerous creosote buildup and maintains proper draft for efficient burning. Stove maintenance includes regular cleaning of fireboxes, replacement of worn gaskets and dampers, and inspection of stovepipes and connections. Many Amish communities include skilled metal workers who can repair or modify heating equipment as needed. Seasonal preparation for heating extends far beyond wood cutting to include comprehensive home winterization. Gaps around windows and doors are sealed with natural materials such as rags, paper, or wooden strips. Storm windows, often homemade, are installed to provide additional insulation. Roof maintenance ensures proper protection from snow and ice that could affect heating efficiency or create moisture problems. Alternative fuel sources supplement primary wood heating when necessary or available. Some Amish communities utilize agricultural waste products such as corn cobs, which burn cleanly and provide good heat output. Compressed wood pellets, while requiring special stoves, offer consistent burning characteristics and efficient storage. In areas where available, deadfall and storm-damaged trees provide additional fuel sources that require minimal processing. Heat recovery techniques maximizes the utility of generated heat. Oven heat is captured by leaving oven doors open after baking activities, allowing residual heat to warm kitchen areas. Hot water generated for cooking or cleaning is used for multiple purposes before cooling, capturing all available thermal energy. Ash from wood burning, while primarily considered waste, retains heat for extended periods and is sometimes used as a thermal mass in specific applications. Indoor air quality management becomes particularly important in tightly sealed homes heated with combustion appliances. Proper ventilation strategies balance the need to retain heat with the necessity of maintaining fresh air circulation. Small, strategically placed vents allow controlled air exchange without significant heat loss. Understanding of natural air circulation patterns helps position stoves and manage airflow for both heating efficiency and air quality. Backup heating strategies prepare families for equipment failures or unusual circumstances. Multiple stoves or heating devices provide redundancy in case of primary system problems. Emergency fuel supplies, carefully stored and rotated, ensure continuous heating capability during extended cold periods or supply disruptions. Knowledge of temporary heating methods, such as safely burning materials in fireplaces or improvised heating devices, provide security during crisis situations. Regional adaptations reflect local climate conditions and available resources. Amish communities in colder northern climates typically rely more heavily on coal or implement more aggressive insulation strategies. Southern communities may utilize different wood types or rely more extensively on passive solar techniques. Coastal communities adapt to high humidity conditions that affect both fuel storage and heating efficiency. Economic considerations significantly influence Amish heating strategies. The cost-effectiveness of wood heating compared to conventional systems provides financial advantages that align with community values of frugality and self-sufficiency. However, the substantial labor investment required for wood preparation, stove maintenance, and system operation represents a different type of cost that community members willingly accept in exchange for independence from commercial energy systems. Safety protocols surrounding combustion heating are deeply ingrained in Amish household management. Children learn early about fire safety, proper stove operation, and emergency procedures. Adults maintain constant awareness of fire hazards and implement preventative measures such as proper ash disposal, clearance maintenance around heating equipment, and regular safety inspections. Fire extinguishing materials, typically sand or water, are readily available in areas where heating equipment operates. Modern innovations occasionally find acceptance within traditional heating approaches when they align with community values and enhance safety or efficiency, without compromising core principles. However, any modifications or improvements must pass through community evaluation processes that consider their impact on traditional ways of life. Health considerations related to heating methods receive careful attention. Indoor air quality is monitored through practical observation of family health and comfort levels. Proper humidity maintenance through water containers placed on stoves prevents excessive dryness that can cause respiratory problems.
Carbon monoxide awareness, while not measured with modern instruments, is maintained through understanding of proper combustion and ventilation practices. Seasonal variations in heating strategies accommodate changing weather conditions and daylight patterns. Early fall heating focuses on taking the chill off homes while maintaining comfortable temperatures for harvest activities. Deep winter heating strategies maximize heat output and retention during the coldest periods. Spring heating transitions gradually reduce heating intensity while maintaining readiness for unexpected cold snaps. Storage and logistics of heating fuels require significant space and organization. Wood storage areas must accommodate large quantities of fuel while protecting it from moisture and pests. Coal storage, when used, requires different considerations due to the material's different characteristics and potential for spontaneous combustion if improperly stored. Kindling and fire-starting materials must be kept dry and readily accessible for reliable fire starting. Tool and equipment management supports heating activities throughout the heating season. Axes, mauls, and splitting tools require regular maintenance and proper storage. Shovels, ash containers, and cleaning tools must be readily available for routine stove maintenance. Spare parts for stoves and heating systems are often fabricated locally or obtained through specialized suppliers who serve Amish communities. Heat conservation techniques extend beyond basic insulation to include sophisticated understanding of thermodynamics. Strategic use of thermal barriers, such as blankets or curtains, creates microclimates within larger spaces. Understanding of air movement patterns helps optimize heat distribution and minimize losses. Timing of activities to coordinate with natural heating cycles maximizes comfort while minimizing fuel consumption. The cultural significance of heating methods extends far beyond their practical function to embody important community values and traditions. The central role of the wood stove in family life creates gathering spaces that promote family interaction and community bonding. Seasonal activities related to heating preparation provide opportunities for intergenerational knowledge transfer and community cooperation. The rhythm of heating-related tasks throughout the year connects families to natural cycles and seasonal changes in ways that modern heating systems cannot replicate. Educational aspects of traditional heating methods provide valuable learning opportunities for community members. Understanding combustion principles, heat transfer, and thermal dynamics through practical application creates deep, intuitive knowledge that extends beyond mere technique. Problem-solving skills developed through heating challenges prepare individuals for broader life situations requiring innovation and resourcefulness. The complexity and sophistication required for effective traditional heating demonstrate that simple living does not mean primitive or unsophisticated approaches to life's challenges. These traditional heating methods represent more than mere alternatives to modern conveniences. They embody a comprehensive approach to home comfort that integrates practical skills, community cooperation, environmental stewardship, and cultural values. The effectiveness of these techniques, proven through generations of successful application, demonstrates that comfort and warmth can be achieved through methods that emphasize human skill, natural resources, and community support rather than dependence on external energy systems and commercial infrastructure.